Good day all. Today we'll be looking at another example on Armature reaction. The question says a 4-pole generator supplies a current of 143 ampere. It has 492 armature conductors when delivering full load. The brushes are giving an actual load at 10 degree. Calculate if the field winding is shunt connected and takes 10 ampere. II if the field winding is series connected. Calculate the demagnetizing ampere turn per pole if the generator is wave wound or lap wound. Now, for us to, this tells us that what? Our number of parallel paths is what? 2. Why this tells us that our number of parallel paths is same as a number of pole, which is equals to what? 4. So we are asked to get our what? Demagnetizing ampere turn per pole if the generator is this and that. So let us solve for the first case. Now the first case will be if we are dealing with a shunt generator that is what? Wave wound. Now in that case, now before I go further, for your shunt, for your shunt connected situation, we are giving field currents. Now our ATD or demagnetizing ampere turn per pole is given to us as our angle all over 360 times our Z. Now all this while we have been using our I just like that because we are considering a general case. But in this case, when they are specific about it being shunt, the current we use at this case is what? Our armature current. Our what? Armature current. We use our armature current at this case because it is the what? The total current. While in series, like we said, in series, all our current is what? Equal. So for us to get our armature current, looking at the diagram of a generator, the generator converts mechanical into what? Electrical. So our current will be coming from the armature and going towards the terminal and to the field magnet. So we are given that our IF is what? 10 ampere, and told that our load current, or the one going to the load, which is the one that the generator supplies, is what? 143 ampere. See it over here. Now for us to get our armature current, we'll be using KCL, which is the number of current entering into a node. This node is equal to the number of currents leaving the node. So we have that our IA is equal to IF plus IL. Our IF is what? 10, and our IL is what? 143. The total is what? 153 ampere. So this is our armature current. So we can come over here and still write it down. Our armature current will be what? 153 ampere. Now, knowing this, we can now simply impute in our formula and get the answer. Our angle is what? 10. We'll be dividing it by what? 360 times your number of conductors, which is what? Your 492. Then you multiply it with your armature current all over what? Since we are dealing with what? Wave. For the first case, we'll be dealing with wave. So our A will be what? 2. So imputing this in your calculator, So we'll be having that, we'll be having our answer to be 1045.5. So approximating to the nearest whole number, we'll be having what? 0.6 ampere turns. So this is for the first scenario when it is what? Shunt, and also when it is what? Wave wound. Now for the second scenario when it is lap wound. Can I write this over here? 1046. Okay, that is for when it is what? Shunt. So for the second scenario when it is lap wound, only thing that will be changing here is the value of our A, which is what? 4. So we'll come over here and we'll change this value. We'll change that value to what? 4. Now imputing into your calculator, you have that for your shunt, you have 522.7. So you can approximate this to be to whole number, which is 523 in what? Ampere turns. So we have gotten for the two cases, for the two wound under shunt. Now we'll be changing over to that of that of series. So if we change this to series, and we'll be solving for the first one, which is what? Wave wound. Now the only thing that will be changing this time around is our what? Our current value. We won't be using Armature current this time around, but just the current that was supplied. Like we said in series, the current is what? Equal. So if at the terminal, this is what you are measuring, this is the same current is flowing through the whole system. So there is no shunt current to kind of increase our armature current, because in series in this case, so long one current is and they told us it is supplied, so this is where we are receiving our currents, which is what? 143. This field magnet also experiences this current, but it doesn't have a different value for it. 143 still goes through this, 143 goes through this, and still come out through here. So in series, current is what? Equal. So for that sake, for the sake of that, we'll only change our I to, you can still leave it as our armature current since it's still correct, because our armature current is the one producing that current and it's still 143. But for the sake of clarity, let us remove the A since we're dealing with what? Series. So if that is the case, our current here will change from 153 for the armature one, now back to what? 143. So this value will change here now. So imputing this in your calculator, and another thing, we are dealing with what? Wave and not what? Lap again. So our A will be what? 2 and not 4. So we have for our wave that our series, we have an answer to be 977.16. So to the nearest whole number, this is the answer. Now over to that of our lap wound. It's quite simple. What will be changing will be the value of our A, which is what? This. It will be changing to what? 4. Now imputing that in you have that your answer is what? 488, okay, 0.5. So approximating will be having 48 what? 9 ampere turns. So this is for your series wave. This is for your series what? Lap. This time around we are doing what? We did the what? Lap. This is for your series lap. When you change it to 4, it is lap. But when it is wave, this is what? 2. Now, the second part of our question is demanding for the number of extra photon necessary to neutralize this demagnetization in each case. Now, we're not interested in what the extra turn per pole. So we have for our first case, which is what shunt and what wave. Now we're dealing with the B parts. Now, for this case, we have that our now we have our extra turn per pole is given to us as our ATD. I will be using the one that we got from the A part of this particular set of question for this particular condition. Now, our I will be I shunt. The I will be using in this case will be what I shunt. Why that of series will still remain your 143. But for your shunts, so it's only for your shunts that some things are changing. All this while we have been solving and we have just been assuming that the generator is in serious connection, like the field it has a serious connection. But now they're specifying that this is what shunts. So the only change is just in their currents. That's what is changing in the two cases. So far, we have been solving assuming that it is what series connected. But in this question, we have now been introduced to what shunt connected. Now, for the first case, when we are solving A, our current was no longer the one supplied at the terminal, that's the load current. Instead, we are using the armature current. And in this case too, we'll be dividing by what? I shunt and not just what? I. So inputting our answers for our shunt wave, we had that our ATD per pole was 1046 over our shunt what? Current. This is it. Now dividing, you will have that your answer is what? 104.6 tons. So that's for the first case, shunt wave. This is our answer. Now for the shunt lap, will anything change? Yes. For the shunt lap, we got that our ATD to be 523. So we'll be replacing this value here with what? 523. And hence our answer will be what? Changing to what? 52.3 tons. That's for the shunt lap. Now for the series wave, we have that our ATD to be what? 977 over. Now since we're dealing with series, we're no longer interested in what? I shunts, but just what? I, which is what? Your 143. Now dividing, we'll be having approximately 7 tons was what used. Now for our series lap, our value here will change to 489. and imputing this in your calculator. We are having approximately 3 tons. So that's all about the question. So the trick is just to know whether it is shunt or series, but in most cases we do assume it is what? Series. But when it's specified as a shunt, you should now be interested in getting your armature current. Your armature current will help you to get your demagnetization MMF or amp turn per pole. Then for your extra turn under the shunt, you'll be using the what? Shunt current. Thank you and God bless you. Subscribe to the channel and see you in the next video.